In this video, we shall see how the subnetting is done for each of the subnets. So the first subnetwork address is network address is 204.17.5.0. Here the host range from 1 to all ones and 0. If I make this 1 as 1, I mean if I make this bit as 1, then it becomes a broadcast address. So the host ranges from 204.17.5.1 to 204.17.5.30. So what will be the broadcast address? It will be 204.17.5.31. So this will be the broadcast address and this will be the network address for subnet 1. What happens for subnet 2? It will be 204.15.5.32. That is the next address of the previous subnet. Following? So here the host range from 204.17.5.33 to 204.17.5.62. What will be the broadcast address? It will be 63, right? Similarly, and one more thing, total number of addressable host will be 30 each. Okay, actual addresses are 32, but however, usable IP addresses will be 30 because one goes for network address and one goes for broadcast address, right? So, subnet 3 will be 10. If you just observe the subnet IDs, it is 0 for subnet 1, 1 for subnet 2, 2 that is 010 for subnet 3 and 011 for subnet 4, right? It goes on to create 8 subnets, and the subnet mask is /27. Host address ranges from 1 to 30, 33 to 62, 65 to 94, 97 to 126 and so on, right? I would strongly recommend you to take a pen and a paper and solve it manually. Okay, these are most confusing set of problems. So the first type of problem is to determine the various addresses, first host address, last host address, broadcast address and so on. Second type of problem is on this, wherein you'll be asked to create a required number of subnets given an IP address. So you should be able to figure out what should be the subnet mask and what are the various subnets, the host within those subnets, etc. Take one more example, wherein I want to create 8 subnets for a network 204.17.5.0. So this is a network address. Here I want to create 8 subnets. How do I do that? Okay. So it is something like this. So for this router, I will have subnet 1, 2, 3. For this router, I'll have again 3 more subnets. So this comes out to be 6 subnets. And one more subnet is actually the internet to which each of these routers gets connected to. In fact, the internet is itself considered to be a subnet. Clear? Right. So here, again, if you observe the IP address, it is class C IP address, class C address, and I have 8 bits in my host part. So in order to create 8 subnets, I need 3 bits. So remaining 5 bits will be used for the host part. Okay. So each of the routers is attached to the 4 subnetworks. One subnetwork is common to both the routers. Also, each router has IP address for each subnetwork to which it is attached to, right? Each subnetwork could potentially support up to 30 hosts. Since we need 8 subnetwork, it is a class C address. Possible number of hosts will be 30. So you have to remember these two things. The more host bits we use for a subnet mask, the more subnets we have. However, more the number of subnets, we will have lesser number of hosts per subnets, because in order to have more subnet, I extend my host portion. This will eventually lead to lesser number of host bits, which is lesser number of hosts in each of the subnets. Yeah. So if we use the mask 255.255.255.240, so the breakdown is something like this. I have the last 8 bits. So I have 4 bits for my host addresses. So in this case, we can have up to 16 subnets because I have 4 bits for the subnets and 4 more bits for the host, right? This was all about your class C, wherein we had 8 bits for the host part. However, if your IP address is class B address, then we have 16 bits to represent the host and 16 bits to represent the network. So here the natural mask is 255.255.0.0 or it is written as /16. So any extension in the host part is nothing but we are creating the subnetwork, right? So if at all I make use of the mask something like this 255.255.248.0. Now what does this mean? I am creating 2 to the power of 5 subnets, that is 32 subnets, and each of these subnets will have 2 to the power of 11 minus 2 hosts each, right? This is what is being explained here. So using 5 bits from the original host bits for subnets, we have 32 subnets, and remaining 11 bits for the host allows each subnet to have 2 to the power of 11, that is 2048 minus 2, that is 2046 devices in each of these subnets, right? Yeah, this is one more example. Again, such examples might be asked in your quiz, wherein we need to determine whether both these devices falls in a same network, right? So device A's IP address is 172.16.17.30/20 and device B IP address is 172.16.28.15/20. So very clearly to solve this is to AND it with the subnet mask. That is the only solution. Just by seeing it visually, you are not supposed to come to a conclusion that it belongs to the same network or on a different network. Okay, so write down the binary form of it, perform the AND operation and check out what is the network address. So if you just look at the network address of both the devices, it is 172.16.16.0. so we can clearly tell both the devices belong to the same network, right? One more example, given a class C network of 204.15.5.0/24, subnet the network in order to create the network with the following requirements. This is one more type of example wherein the requirements is for this particular router, we are supposed to create 3 subnetworks with 14 hosts, 28 hosts, 2 hosts. For this, we are supposed to create 7 hosts, 28 hosts and 2 hosts. As I was telling you before, the connection between the 2 routers again is a subnetwork, right? So the first step to solve such problem is determine how many number of subnetworks are required. So it will be 1, 2, 3, 4, 5, nearest power of 2, right? So nearest power of 2 is 8. That means I need 3 bits of my host part in order to create the subnetworks, right? After this, determine the number of hosts that are required. So it is maximum number of hosts is 28. So how many bits we are left out with? 3 bits if I used to create the subnetworks. Remaining number of bits will be 5. So with 5 bits I'll be able to create 30 usable addresses. So that will be sufficient for designing this network. We shall see how it is being solved. So total subnets required are 5. Largest subnet must support 28 hosts. So start with the subnet requirement. To create 5 subnets, we need 3 bits in the host part. So this leaves 5 bits in the host portion of the address. So how many hosts does it support? It supports 30 usable IP addresses. So this actually meets the requirement. So once determined, it is possible to create a network with class C network. So this is how we create the subnetworks. So network A network address will be 204.15.5.0. Host ranges from 1 to 30. Next, 32 will be the broadcast address. 33 to 62 will fall for subnetwork B. 63 will be your broadcast address. 64 becomes your network address. 65 to 94 will be your usable addresses. 95 becomes your broadcast address. 96 becomes the network address. 97 to 126 becomes your IP addresses. 127 becomes broadcast. 128 becomes network address, and finally 129 to 158 becomes the usable IP addresses, right? So again, I would strongly recommend to solve such problem using a pen and a paper. Now there is some disadvantage. Can you figure out what could be the disadvantage in this case? Just look at this requirement and what solution we have proposed. You can just pause this video for a moment and think over it. Yes, obviously the requirement in subnetwork C, subnetwork A and subnetwork D is just 7, 2 and 14 hosts respectively. But however, we have given extra, that is 30 hosts with 30 addresses for network C, 30 for network D and 30 for network A, which is not required, but still we have no other way, and we simply divided the subnetwork based upon the subnetting concept. Okay, so the previous examples of subnetting, we applied the same subnet mask for all the subnet. So this means that each subnet has equal number of hosts. So in most cases, having same subnet mask, it ends up in wasting the IP addresses. So as we just discussed this, right? So to overcome it, we have something called as variable length subnet mask, wherein for each of the subnet we specify a different mask. Okay, we shall see this example and the discussion in our next video.